Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will deep dive into the concept of service mesh using Istio. This video tutorial is going to be both theoretical as well as practical. And in the practical section, I'm not only going to show you how to install, configure, set up Istio, but I'm also going to show you how Istio works internally. That is, how Kube API server talks to Istio and how Istio does the sidecar injection in real time. So it's going to be a very interesting video. Probably you will not get this information anywhere else. So please try to watch this video till the end. At a high level, the video tutorial covers the following things. What are admission controllers? Why are they needed and how they actually work? What are sidecar containers? What is a service mesh? Why do you need a service mesh for your Kubernetes cluster? Pros and cons. Then we will learn how to install and configure Istio. We will learn the traffic management using Istio, which is a popular use case of Istio. And to implement the traffic management, we need Istio's custom resources that are virtual services and destination rules. So we will learn all of these things using a demo application. The demo application is going to be a multi-microservice architectured demo application. It is provided by Istio and we are going to use that. Then we will learn the features of Istio such as circuit breaking, mutual TLS, observability, and others. Towards the end, we will also learn the concepts like gateways, which helps users expose the services in the service mesh to the external world. We will also compare gateways with Ingress and Ingress controllers. All the notes related to this video is shared in this GitHub repository. All the commands that I'm going to use, the YAML manifest, everything is available in this GitHub repo. So you can star the repo, fork it, watch it to get the continuous updates. So let's start with the important concept, that is, what is a service mesh? Why do you need service mesh? And how service mesh actually works. Let's take the what aspect first. As per the definition, service mesh helps you with the traffic management of your Kubernetes cluster and especially the east-west traffic management of your Kubernetes cluster. Now, what does east-west mean? Let's take a simple e-commerce application for understanding this. So let's say there is an e-commerce application that is deployed on a Kubernetes cluster. And this e-commerce application is a very simple one, which is created using only 4 microservices for easiness, where you have a login microservice, then you have a catalogs microservice, payments microservice, and notifications microservice. So the user workflow is any user who logs in to this e-commerce application, catalogs is displayed where user can see a catalog of product. Then catalog talks to payment if user selects a product and if user is interested in purchasing the product, catalog talks to the payments. And either if the payment is successful or failure, payments talks to notification so that user gets a notification about the payment status. Now this is the workflow, but if this e-commerce application has to be exposed to the customers or to the users outside the Kubernetes cluster, A Ingress is created for the login microservice. It can be Ingress or service of type node port or load balancer type, anything, but somehow user has to access the login microservice from outside the Kubernetes cluster. Only then the e-commerce application can be used. So this is the workflow, and in this workflow, the traffic can be divided into two parts. One is the ingress traffic, or the traffic that comes from outside the Kubernetes cluster. This is called as north-south traffic. And the other one is the internal service-to-service communication, where login talking to the catalog, catalog talking to the payments, or payments talking to the notifications. This does not require any ingress traffic or egress traffic. So this one is called as east-west traffic. So the traffic between the services within your Kubernetes cluster is usually referred as east-west traffic. And the traffic that comes outside your Kubernetes cluster, which is the ingress, or traffic that flows outside your Kubernetes cluster, which is egress, is called as north-south traffic. So the definition of Istio says, Istio can help you with the traffic management. That is the traffic between the services of your Kubernetes clusters. Now this leads to a question, why? Right? If login can already talk to catalog, and if catalog can talk to payments, payments can talk to notifications, because they are already within the Kubernetes cluster, they can either talk to each other using the service names or any other mechanism, right? One Kubernetes service can talk to other Kubernetes service. Unless there are any network policies or something mentioned, they can directly talk to each other. In that case, why we need a service mesh? So the answer to it is, yes, of course, service to service communication is possible, but Istio enhances or adds on capabilities to your service to service communication, such as mutual TLS. Now, what does mutual TLS mean? So if you install Istio and if you allow Istio to this particular namespace, then Istio says that it can secure the service to service communication. Now, by default, these services are talking without any TLS, without any security measures. So if you install Istio, Istio adds mutual TLS between this communication, where login microservice will have a certificate, catalog microservice will have a certificate generated by the certification authority of Istio. You don't need to install anything. And when login wants to communicate with catalog, both login as well as catalog will display their certificate to each other. And only when both of them trust each other, a communication is established. This is slightly different from the traditional TLS, because in the traditional TLS approach, usually client is the one that displays certificate to the server, and if server acknowledges, then a trust is established and communication is established. But here, Istio is talking about mutual TLS, which is advanced level of security. Don't worry, we will also learn how this thing happens practically. But talking about the why aspect, point number one is Istio adds the mutual TLS for secure service to service communication. Not just that, Istio adds other capabilities such as advanced deployment strategies, where using Istio, you can implement deployment strategies like Canary, AB, or blue-green deployment in a very easy way. Let's try to understand, if any one of you are not sure what is Canary. So let's say catalog is talking to payments, where you have a catalog service which is already talking to payments. Let's call this as version 1 of payments. And you want to introduce a new version of payments with advanced features. Let's call it as payments version 2. You have tested it on your test environment, dev environment, staging environment, but still you're not confident to directly put it out in the production for all the customers. So you can use deployment strategies like Canary, where initially you can request your catalog service to only send 10% of traffic to the new version, that is V2, and rest 90% to V1. Once you look at your Prometheus metrics or you run some tests or the users are satisfied, then you can increase the percentage to 20, probably 50, and eventually you can get it to 100. And then you can remove or delete payments version 1. So this is how Canary works. Similarly, there are multiple deployment strategies, like you have AB, you have blue green. Implementing these deployment strategies is not straightforward on a Kubernetes cluster. It takes modification of a lot of resources, adding custom controllers. But with Istio, you can do it with little less difficulty. I think these features, mutual TLS and Canary, already explains the why factor of service mesh, why some customers go with it. But to add to these features, Istio also adds another powerful capability to your Kubernetes cluster, that is observability. So Istio comes with Kiali out of the box. You just need to enable it. And what Kiali does for you, it keeps a track of your service to service communication. Anyway, service to service communication is going through a service mesh. So it keeps a track of this information and it will help you understand how your services are behaving, what are the metrics. It can help you with understanding the health of your services, behavior of your services. So you don't need to install any additional observability platform on your Kubernetes cluster. It is taken care by the Istio service mesh itself. There are so many other features like circuit breaking. It can implement traffic splitting. So if you keep talking, there are more features that Istio can add to your Kubernetes cluster, but these are some of the important features. Now I think this explains the why factor. We already learned what is a service mesh. We learned why service mesh is implemented by customers on your Kubernetes cluster. Now it's time to understand how. Because we learned that Istio can add these features. These features are not that easy to implement. If we take example of mutual TLS, it's not easy for Istio to implement mutual TLS on your existing Kubernetes cluster. How Istio does this? I'll make it as simple as possible. So what Istio does is in all the pods of your Kubernetes cluster, of course, the namespaces which Istio has access to. So within each and every pod, what Istio does is it adds a new container that sits next to the actual container of your Kubernetes pod. And this new container is called as Sidecar container. What is inside this Sidecar container? So the Sidecar container has a Envoy Proxy application. So it's just a proxy server. And what this proxy server does is it handles the traffic management of your Kubernetes pod. That means any request that is coming to your actual container or any request that is coming to your pod, now it will go to the Sidecar container, and any request that is also going outside your Kubernetes pod goes through the Sidecar container. So it will handle the complete traffic. And this Sidecar container is installed in each and every pod of your Kubernetes cluster. Let's take the same e-commerce application as example so that you understand it in a better way. So we have catalog. Then we have payments. in our previous example. And in general sense, without Istio, what catalog does is catalog initiates a API call with payments. So catalog will find the service URL of the payments, and using that, it will initiate an API call. The service URL, catalog can get it from the config map, or catalog gets the service URL of payments from the command argument. Anyways, but it will initiate a API request and payment will send the response back. Now with service mesh, what happens is the same workflow. Now catalog, when it tries to initiate a API call to the payments, request will be taken by the sidecar container. So the API call is intercepted by the sidecar container. It goes to the sidecar container, and from there, it will go to the payments. Again, the sidecar container in the payments will intercept the request, and then it goes to the payments. So both the inward traffic as well as the outward traffic are intercepted by the sidecar containers. How will that help? If you take example of mutual TLS, you will understand how sidecar containers are managing the traffic. So the same example, when catalog tries to initiate an API call with the payments, so this sidecar container intercepted the request, and here it will add a certificate, or it will initiate a TLS traffic. And when this goes to the payments, this sidecar container will again intercept the request, and here it will try to verify the certificate. Along with verifying the certificate, it will also display its TLS certificate to the catalog service, because it's a mutual TLS, right? Both catalog and payments trust each other only if they have the valid certificates. So if these sidecar containers do not exist, then developers have to write this logic within their application, or you need any third party to implement this mutual TLS. So what Istio does beautifully is, without making any change to your application, without making any significant change to your cluster, within every pod, it is just adding a sidecar container. And this sidecar container implements mutual TLS. It will help in implementing the Canary model of deployment. This sidecar container will help in implementing the circuit breaking. And the most important one, these sidecar containers help in the inbuilt observability of the Istio. Every example we can understand using the same concept of sidecar container, even with observability, because sidecar containers are intercepting the request. They know which services are being accessed, and what they do is they will send all this information, the sidecar containers, to Istio D. So Istio D is basically the primary component of Istio. It receives all this information and it keeps the track of all the service metrics, which will help in the observability. Similarly, Canary model, circuit breaking, we will come to know when we move towards the demonstration. So this is the how part. But again, you can ask me a question that, Abhishek, okay, it's clear that Istio is adding a sidecar container. How? Because if Istio has to add a sidecar container to each and every pod that is created on the Kubernetes cluster, Istio needs to get that information from somewhere. If someone sends a request to the API server for a pod creation, Istio should be immediately notified that, okay, someone is requesting me for creating a pod. Do you want to add a sidecar container to it or not? If API server is not notifying Istio, a pod gets created and sidecar container is not added. So how does the communication between the API server and Istio take place? For that, Istio use a concept called admission controllers. Of course, Istio uses a little advanced concept of admission controller, which is called dynamic admission control or admission webhook. We will go to that, but before that, we should understand the concept of admission control. So, what exactly is an admission control? If you take a simple request to the API server, there is a user and user wants to create a pod on the Kubernetes cluster. So using kubectl apply -f or kubectl create, user will try to create this pod. Request goes to the API server. There is a component in the API server which will basically verify if the user is authenticated and authorized to perform this request or not. If the user is authenticated and authorized, then API server will take this object and persist the object in the etcd or stores the object in etcd. So this is step 1 and step 2. Step 1 is to verify the authentication and authorization. Step 2 is to take the object and persist in or store it in etcd. Admission controllers come in the second step, where they can intercept this request to the etcd before API server creates those objects in etcd. Admission controllers can mutate or validate the objects. Mutate is nothing but modify. So admission controllers can modify or they can also validate, that is verify few things in the pod resource or any resource that is getting created. For example, let's say you want to create a persistent volume claim and you did not add a storage class in the persistent volume claim resource. So the request goes to API server. You have authentication and authorization. So API server tries to add that resource to etcd. Before adding, there is an admission controller that is called storage class admission controller, which comes into picture. It will see if the PVC has the storage class field or not. If it does not have, it will mutate the object, and in the object, it will add the field to your PVC creation request. Mutation admission controller will add a new field, and that field is called storage class is equals to XYZ, and then the object is persisted into etcd. Like that, there are some 30 plus admission controllers that are available by default in every Kubernetes cluster. Of course, sometimes they are disabled by some distributions, but there are 30 plus admission controllers, and these admission controllers, you don't have to install them. They are pre-compiled into the API server. So API server already has code for all of these 30 plus admission controllers. You can just enable or disable them. Abhishek, how do I know what are those admission controllers? If you simply go to this page called admission controller reference, so here you can see all the admission controllers. So this is the one that I was talking about, default storage class. Similarly, you have namespace access, you have node restriction, you have pod security, you have resource quota, you have service account. So you have 30 plus admission controllers. Can we see a practical example? For sure. Let's try it on our Kubernetes cluster so that you can understand it in a better way. So let's take the Kubernetes cluster. So I have this Kubernetes cluster that is running. It's a Minikube cluster. You can use any Kubernetes cluster. That's okay. And you can verify first that the admission controllers are enabled on this cluster or not. So just log into the Kubernetes cluster and you can go to this file called kubeapiserver.yaml, which is usually present in this location, etc kubernetes manifest, and you have this file called kubeapiserver.yaml. And in this file, you will see that the kube API server is passed with an argument, command argument, which is enable admission plugins or admission controllers And these are the admission controllers that are enabled on the cluster. In your case, this number might be more or it can be less because it depends on the distribution of Kubernetes that you are using. Of course, you can add new fields to it, restart your API server, or there is also a Kube API server which you can run and you can add more admission controllers. Like I showed, these are the list of admission controllers, out of which probably 10 are available on my cluster. Namespace lifecycle, limit ranger, service account, default storage class, which I was talking about during the theory, and the other admission controllers. Now let's try to perform the demo of the same thing, that is default storage class, where what I'm going to do is I'm not going to provide the storage class in my persistent volume, and let's see if the object gets mutated or not. Because the storage class controller is already available on my cluster, it should get mutated. So we can go to the GitHub repository and go to this folder called default admission controllers. Just for copying the YAML manifest, I have already provided it here. So I have two examples for mutation 1 and validation 1. Let's go to mutation. And this is the storage class file that I have, where you can see that I don't have the field for storage class, default storage class. Okay, let me call this as pvc.yaml, and let me put this file here. Now I will do kubectl apply -f pvc.yaml. You will notice all these steps have taken place. Like the PVC request is sent to API server. It has authenticated and authorized my request. Then the storage class mutation controller impact or intercepted the request before object is stored into etcd, and it has added this field kubectl edit pvc my claim. So if we scroll down, so this is the field that I was talking about. It said storage class standard, which was not available. Again, if I go back to my GitHub repository, so that particular field called storage class standard is not available in this YAML manifest. This concept is called as mutation. Similarly, you can also perform the validation, where if you go to the validation folder, let's say I will create a resource quota to my namespace. That is nothing but I will restrict my default namespace to certain amount of CPU and RAM. So the namespace cannot use more than 1 CPU and 2 GB RAM. This is the restriction that I'll put on my namespace. kubectl apply -f quota.yaml. And now intentionally, I will create a pod which is requesting for 10 GB RAM. Okay. The namespace itself can only provide or use 1 CPU and 2 GB RAM, but the pod request that I'm going to make is of 10 GB RAM. Now, API server should initially or ideally create this object, but because I have a validation admission controller, validating admission controller, it should intercept my request and it should throw an error saying that, hey, you cannot do it because there is an admission controller which says maximum of only 2 GB RAM can be used by any pod or the maximum of namespace. kubectl apply -f pod.yaml. So we got this error. And who sent this error to us? It is the same admission controller that is enabled on my Kubernetes cluster. So just to quickly show you one more time. Here, there is this admission controller called quota. It should be somewhere here, resource quota. This is the validation admission controller which intercepted my request and it sent an error to me that, hey, you cannot do it. Perfect. So this is how admission controllers work. But you should still have a question that, Abhishek, all these admission controllers are already compiled to the API server. So API server can basically call these admission controllers. In our case, we are talking about Istio. And Istio is an external component. It is not the control plane component of Kubernetes. So how API server can forward the request to Istio? Will Istio write their own admission controllers or will they write any other thing? I will explain this once we do the demonstration of Istio, because the concept of dynamic admission control is not that simple to understand. So I'll initially show you the demonstration of how Istio works, and then we can come back and understand this piece of logic of how API server connects to the webhook of Istio, where Istio adds a dynamic webhook or dynamic admission webhook. So we will see that concept after the demonstration. The installation of Istio is pretty straightforward. Just go to this document. Link is also available in the GitHub repository. And if you scroll down, you will find this curl command, which will download a folder on your local machine. And that folder will have all the installation scripts, cleanup scripts, sample for our demo as well. So I will go to my terminal and I will run this command on the terminal. If you're on Windows, you can use git bash. So it is downloading this folder 1.21.2. And where is it downloading from? It is downloading from Istio's GitHub repository. And this folder will have everything that is required. So let's see cd istio star. So let me do cd istio 1.21.2. So it has the samples which we can use for our demonstration. It has the manifest that will help us the installation, and also bin, which has a command line utility for Istio that is called Istio CTL. Just like for Kubernetes, you have kubectl. Istio also has something like Istio CTL. What are the next steps? We got that change the directory to 1.21.2, which we already did. Just export this path where Istio CTL is available. So if I just do ls on the build folder, so this is the binary Istio CTL, which will help us to connect to Istio through the command line. Now we will use the same Istio CTL to install Istio as well. Istio CTL install profile demo -y, which is yes. So there are multiple profiles Istio provides you, like production, development, demo. So demo means it will come up with the default configuration values that are useful for your demo. If you're going with production, then you will get more strict values. Demo is the best place to start with. Shouldn't take much time. Hardly it will take 1 or 2 minutes. Okay, now Istio is installed. So it installed few components, like I mentioned, Istio D, which is the primary component of Istio, which performs the control plane related to Istio and all the main concepts of Istio. Then you have an egress gateway and ingress gateway. We will come to this topic when we talk about gateways. So installation is complete. Then we can proceed with enabling or allowing Istio to access the default namespace. So for that, you have to run this command where you need to add label to the namespace where you want to give Istio permissions to. So I said Istio injection enabled on the default namespace using this kubectl label command. Now we can proceed with deploying a simple application. And this application is a book info application where, this is the architecture of the application. It's not very complicated application. It is just built using 4 microservices where we have a products page, then we have details of the product, we have multiple versions of the review service, and then we have a ratings service. So products basically talks to reviews and details, and review service talks to the ratings. So app would look something like this once it is installed and running. So you will see some products and you will see the ratings of the product, and you will also see some reviews if they exist. And what this book info application does is just for the usability of the user, or just to give user a better experience. Each microservice is written in different programming language. You can see product is written in Python. This is written in Java. This is written in Node.js, and details is written in Ruby. Of course, there is no significance to it. It's just a polyglot application so that you feel that you have exposure to using an application on Istio with different programming languages. And if you watch carefully, reviews service, there are 3 different pods for the review service: version 1, version 2, and version 3. That means all the other applications have just 1 copy, but reviews have 3 copies, that is 3 replicas of pods, where each pod is of different version, so that you can also learn the things like Canary model of deployment. This application also helps you in that. Now let's proceed with deploying this application and learn about it further. So kubectl apply -f, and it started creating the services and deployments. If you just do kubectl get, so we can see all the pods are up and running. And what's important to note is each pod in the default namespace, because we have enabled Istio injection, we can see there are 2 containers inside each of these pods. 2x2 containers are in the running state. And we can also do kubectl edit pod. Let's pick up any one pod. You will see 2 containers. One is the Sidecar container and one is the actual container. So this is the actual container, which is book info details application. And if you scroll down, you will see another application here, which is the Sidecar container. And the Sidecar container comes with bunch of arguments, environment variables, everything that is required for the Sidecar container to manage the traffic of the pod. So likewise, in each of the container, you can just log in and see, you will see the Sidecar container configuration. Now let's move to the next steps, where I just want to expose this application to outside world and to show you how the application looks like before we perform further activities like mutual TLS and other things. Let's just run this application on our Kubernetes cluster. So deploying is done. Now I will expose this application to outside world. We have a command here. Don't worry, we will learn what this virtual service, what are the gateways. But firstly, we want to see the application. I will also run Minikube tunnel so that I can access this application from my browser. If you don't run Minikube tunnel, you can only access it from your Minikube server or from your Kubernetes cluster. To access it from the browser, you would need Minikube tunnel or any kind of port forwarding. So let me keep this window the same and let me open a new tab so that I'll not close the tunnel connection. Okay, so I have created the tunnel as well, and we will export. Basically, what this export commands are doing is it is just forming this URL. You can also run this by your own. It's not required, but just I'm following the documentation. So now you can also access it directly on this particular URL. You don't need to run that export commands. Just this is your local host port 80 followed by product page. Okay, so we have the application up and running. And if you watch carefully, we got the products information. We have the details microservice that is populating the details. We have reviews as well, but we don't have any ratings. If you see my screenshot here or my previous instance of the application, here there are ratings, but the one that we started did not have any ratings. Any guess why? Because reviews is served with reviews v1 version. And if you look at the architecture of the diagram, reviews v1 is not connected to the ratings application or is not connected to the rating service. Only reviews v2 and reviews v3 are connected to the rating service. Probably if I refresh, because the default load balancing of a service is round robin, maybe if I refresh a couple of times, we will see reviews v1 change to reviews v2 and we got the ratings. And probably if I refresh a couple of times more, we will see maybe reviews v3. Perfect. So what is happening here? Product service is talking to different versions or different replicas of reviews pod, where one replica of reviews pod, that is reviews v1, does not have connection to ratings. So probably when this was developed, they did not have anything like ratings, but in reviews v2 and reviews v3, they have information to connect to rating service and get that populated on the home page. Perfect. So we also have this application up and running. So we installed Istio. What are the steps that we perform? We have Istio up and running. We have enabled Sidecar injection. So for each of my pod, I have Sidecar container injected into it. Then I also got a simple book page application up and running on my Minikube Kubernetes cluster. Now let's try to make use of the Sidecar container and implement the features of Istio. So what I'm going to do, now if I just do kubectl get svc, you will get information of all the services. Like probably let's take the product page. And if I do minikube SSH, and if I try to connect to this products page using the service IP followed by the port, I'll just do curl 9080 and we got the information of the products page. Similarly, I can also hit the product page API where I can just say API v1 products. So I can also talk to the products page if I log into the Minikube cluster or if I have access to the cluster IP of the service. But what we learned, Istio enables mutual TLS where someone can only talk to the service if they have the certificate to talk with them. But in my case, I'm just running a curl command. And how did I access it? So by default, Istio runs mutual TLS in the permissive mode. The permissive mode says you can either access the service using mutual TLS or you can also access it without mutual TLS. So what I'm going to show you in the first demo is I will enable, now if we go back, click on mutual TLS, I have this custom resource. So I will make sure that mutual TLS is strict, not permissive. So after I enable this in the strict mode, if I again try to do the minikube SSH and run the curl command, I should not get the display page or I should get some error. Let's see if that happens. So first let's create it. TLS mode.yaml. So we are doing mutual TLS demo and I'll just do kubectl apply -f tls mode.yaml. Okay, let's just give it a couple of seconds. Like if it does not work in your cluster, please wait for a couple of minutes. Sometimes it takes time to reflect the configuration. Let's do minikube SSH again. And this time, let's try out the same command, curl connection reset by peer. Why? Because I'm sending out a curl request. The Istio sidecar container is asking me for the certificate. I don't have the certificate, so it has rejected the connection. So this is how mutual TLS is implemented. Now, if I try to access it from any other service, I'm able to do it. You know, Abhishek, how can you be confident? Because if I just refresh this page, still I'm able to see the review. I'm still able to see the ratings. That means the internal communication is working fine. The catalogs is able to talk to product is able to talk to details. But if I try it using a curl command, that is without any service, then I'm getting this error. So my services are secure. So what has Istio done here for me? Istio made sure if anyone tries to access the service without a proper certificate, it throws an error. So this is how mutual TLS is implemented to secure your cluster. So this is our demo one. Now let's try to demonstrate the Canary model of deployment. Before we go there, we should understand some concepts like virtual service and destination rules. Virtual services and destination rules will help in the traffic management of Istio. In our use case, virtual service and destination rules will help us in implementing Canary model of deployment. Let's see how. So if we take the same book info application where currently we saw that if we refresh, probably reviews v3 will change to reviews v2, or it can change to reviews v1. Now what I want to do is I want to learn the Canary model of deployment, where initially I want all my requests just to go to reviews v1 all the time, and then I will introduce a new version, let's say reviews v2. Then I only want 50% of the traffic to go to reviews v2 and 50% to go to reviews v1, right? So here it is continuously changing at this point of time. Let's make it only talk to reviews v1 initially. So for that, what I am going to do is I'll go to my Kubernetes cluster and I'll deploy this YAML manifest from the GitHub repository. So this is the traffic shifting example. Traffic shifting is nothing but Canary model, where currently I will go to only the old version example. Okay, so this is where virtual services play a critical role, where it is saying virtual service for details, where every request should go to the destination details v1. What is destination? Destination is another custom resource which we are going to create, and in the destination we will mention the subset v1 will only point to the version 1 of details. Similarly, when we are talking about ratings, of course all of them just have version 1. What is important for us is the reviews. So the reviews virtual service is saying any request that comes to the reviews microservice or the sidecar container, they should go to destinations reviews subset v1. Now we have to create this destination, and in the destination I will say request should only go to the pod with version 1. So let's try to do that. First I will say kubectl apply -f old-version.yaml. Right now it is only 50% done because we have created virtual service, but without destination rules it is incomplete. So for the destination rules, now we can scroll down. So the destination rules, I'll also upload this to my GitHub repository. This is the only missing piece. At this point, I'll show you what this destination rules is doing. So it is getting applied. Let's open the destination rules for reviews. And there you can see always it is sending the traffic only to the version 1. kubectl edit destination rules reviews. Okay, so this is the destination rule, and here it is saying if the subset is v1, then only go to the version 1. So there are multiple subsets here: subset v1, subset v2, and subset v3. And we have mentioned that it should always go to subset of version 1 only. We have mentioned that in the virtual service. So the request will go to pod of version 1. So it is applied. Let's go back and see. Okay, it is getting refreshed. It went to version 1, and even if you refresh it 100 times, every time the request will only go to reviews v1, because virtual services and destination rules have explained the sidecar container that request should always go to version 1 only. So this is how they will play a crucial role. They will explain the sidecar container how it should behave. Now I want to implement traffic shifting or canary. So I will make a slight modification. Probably here you might understand it in a much better way. So I will go to traffic shifting example. And here you can see in the virtual service, I have mentioned destination v1 for 50% and destination v3 for 50%. Previously, I just said destination v1 all the time, but now I have explained the virtual service, which explains the sidecar container to send 50% of traffic to version 1 and 50% of traffic to version 3. Again, I'll copy this. Or let's say canary.yaml. Let's apply this kubectl apply -f canary.yaml. And now if you go to the browser, you should see 50% of traffic going to v1 and 50% of traffic going to v3. Let's see if that is correct or not. Okay, it went to v1. Let's refresh again. It went to v3. Let's refresh again. Okay, it's getting refreshed. It's not yet refreshed. So overall, if you make 10 requests, or let's say you make 20 requests, you can see on an average 10 requests goes to v1 and 10 requests goes to v3. So 50% of traffic is shared between both of them. So this is how Canary model is implemented. And now if you are comfortable, let's say your Prometheus metrics or your Kiali metrics or any automation test that you run on the new version, if they are working fine, what you can simply do is you can go to the old version.yaml, or you can even come to Canary and just simply say wait 100 on version 3 and wait 0 on version 1, or you can just remove this block as well. Now let's do apply -f one more time. It's time for the final test where my request should only go to version 3. Refresh again, again and again. You will see the Canary model is successfully implemented, and now your new traffic only goes to version 3. How did we achieve this? Using virtual services and destination rules. In a nutshell, virtual services and destination rules will help the sidecar container how to manage the traffic of your actual container. Canary model is just an example. Along with that, if you have time, you can also explore multiple traffic management examples of Istio. We have covered mutual TLS and traffic shifting, which is Canary. You can also try circuit breaking, request timeouts, and in each of the example, they have shared you the virtual services and destination rules YAML files. It will take a lot of time. If you are interested, you can try, but these are the main things where Istio is quite popularly used. Now that we got an understanding about mutual TLS and how Istio implements traffic management for Canary model of deployment, we got information about sidecar injection. Now let's go back and try to understand the concept of how Istio implements admission controller. If you look at all the other admission controllers, as I've explained, they are pre-compiled into the API server. So whatever the resource quota admission controller that we have tried, or the storage class admission controller, they are all pre-compiled into the API server. So API server clearly knows how to invoke them and what action will those admission controllers take. Either they are going to take mutation or validation. In this case, for Istio to add a sidecar container, Istio should know when a pod creation request comes to the API server, and somehow API server should notify Istio that, okay, now you can proceed with the sidecar injection. So that concept is called as dynamic admission control. I'll make it very simple. This is not even available in the Istio docs. So this happens in multiple stages where the same pod creation request comes to the Kubernetes cluster. API server will perform the authentication and authorization. But here, not the standard admission controllers. There are two special admission controllers, which are called as mutating admission webhook controller and validating admission webhook controllers. They are also available in the documentation. So if you see, along with the traditional controllers or the basic controllers, you have validating admission webhook controller and you have mutating admission webhook controller. The responsibility of these controllers, so they are the ones where they take your input or they take request from the API server and they notify Istio or any other project that wants to implement the sidecar injection or any kind of mutation and validation. So which component of API server is taking this responsibility? It is again an admission controller, which is helping in the dynamic admission control. But this component does not perform the mutation or validation. It only forwards the request to any webhook that is implemented by the project. So Istio is going to implement an admission webhook, which is again a Kubernetes controller. It is part of Istio D. And this admission webhook is called by the mutating admission webhook controller. This webhook is going to perform the mutation logic. It is going to inject the sidecar container and then object is persisted into etcd. It might look complicated. Let me show you practically. Maybe practical might help. So if you go and look for this CRD on the Kubernetes cluster, kubectl get mutating webhook configuration. So this is one CRD that Istio creates. If you try to read through the CRD or custom resource, not CRD, kubectl edit mutating webhook configuration, Istio sidecar injector. So this architecture is too much technical, but it is good to understand. So this mutating webhook configuration CR is submitted to the API server, and this is read by this mutating admission webhook controller. And what it will understand from the custom resource is, it will just look for the rules, where rule says, okay, whenever a pod is created, doesn't matter in which namespace, doesn't matter. Just let me know whenever a pod is created. And how do you let me know? For that, here there is a field called service. Okay. So this custom resource is actually telling the mutation webhook controller that whenever a pod is created, just forward the request to this webhook called Istio D that is available in the Istio system namespace. So mutating admission webhook controller, whenever a pod is created, because the custom resource is telling it to forward the request to Istio D admission webhook, it forwards the request to it. And this Istio D admission webhook takes the API request, it performs the mutation, and then it returns the object back to API server. From there, object goes to etcd. So this is how dynamic admission webhook, or this is how the dynamic admission controller is working. In case of Istio, sidecar injection is taking place. Let's say tomorrow you want to implement something. What you can do is you can also develop your own webhook. Let me call it as, let's say, Abhishek webhook. I can create this Abhishek webhook, but what also I should do is I should also create a custom resource called mutating admission webhook configuration or validating webhook configuration. And in that configuration, I have to clearly say API server, when should it forward the request to my webhook, and what is the path of my webhook, where is it located, in which namespace, and on which path should it send a API call to me. So anybody can implement this dynamic admission webhook, but saying that you need to know how to write a webhook server in Kubernetes and how to create custom resource definitions and work with it. So this is about how Istio works internally to implement the sidecar injection. Of course, this is not available, like I mentioned, in the Istio docs, but if you are very curious and if you want to spend some good amount of time, you can go through this document, dynamic admission control, but it takes a lot of time to understand. Keep that as a note, keep that as a point to be noted. If you are going to spend your time, you are going to spend a lot of time in understanding this in detail. Finally, like I said, Istio also comes with an inbuilt observability. You just need to install Kiali. Kiali is not installed out of the box, but all the information related to your services is collected by Istio. Istio gets the information of the traffic that is flowing into your service, out of your service. What you can simply do is go to the Istio docs, search for observability, go to visualizing your mesh, run this command to install Kiali. Just do Kiali. So, you have. So in my case, I think it is already installed. Let's see, kubectl get pods -a. Yeah, Kiali is already running. In your case, you should run that command. And then what I'll simply do is run istioctl dashboard Kiali. And this should start the Kiali dashboard and it will automatically open it. So this is how I get the Kiali dashboard, and you can look for the graphs, you can look for the applications, workloads, services. So I'm not going into the details of Kiali and the observability because it's a complete different topic where we will take this in the monitoring class, which we will do in the future. But just to give you an information, so Istio has this Kiali where it can help you with the service tracing, dynamic distributed tracing. You can also get the information about your services health. So this is about Istio. I hope you found this video informative. And if you have any questions, do let me know in the comment section.